Welcome viewers, in this video we will see the solved problem based on the DC transient response of RLC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic RLC. The solved problem based on the RLC DC transient. The problem statement is a series RLC circuit has R equal to 50 ohm, L equal to 0.2 Henry and C equal to 50 microfarad. Constant voltage of 100 is impressed upon the circuit at t equal to 0. Find the expression for transient current assuming initially released condition. So series RLC circuit is there, RLC value is given, applied voltage is 100 at t equal to 0. We need to find the transient current. The initial conditions are 0, released condition. So there is no initial storage. Right. Now we'll see, first we need to identify what type of circuit this one. The current is whether under damped or over damped, like that. For that the condition is available. R divided by 2L is less than 1 divided by LC. This condition is there. So we need to find these two values. If it is less than, then the current is said to be under damped. So we need to find these two values, R divided by 2L the whole square, right? R divided by 2L the whole square. So that is nothing but R is 50, 2 into L, L is 0.2, the L equal to 0.2 Henry, that is 15,625. 1 divided by LC, 1 divided by L is 0.2, C is 50 microfarad, 50 into 10 to the power minus 6, that is 10 to the power 5. Now we calculated these two values. So from these two values it is clear that this is lesser. This value is lesser and 1 by LC is greater. In this case the current is said to be under damped condition. Based on that we have two values are available, alpha and beta. Alpha and beta available. Alpha equal to minus R by 2L. Beta equal to 1 divided by LC minus R divided by 2L the whole square root of. So R by 2L minus 50 divided by 2 into 0.2 minus 125. Alpha value is minus 125. Beta 1 divided by LC, square root of 1 divided by LC, that we already calculated, 10 to the power 5 minus R divided by 2L the whole square also already we calculated, 15,625. So it is 290.5. Beta and alpha values are now calculated. The roots are alpha plus JB and alpha minus JB. Right? Roots are complex conjugate. Alpha plus JB and alpha minus JB. Substituting the value of alpha and beta, we can able to find the root. That is minus 125 plus J 290.5 and minus 125 minus J 290.5. So these are all the two roots are available. Now based on that we can go for the expression for current I of S. I of S equal to E divided by L. So this is the third case. RLC circuit, three cases available. Roots are real and equal, real and different. Third case is complex conjugate. So this is coming under complex conjugate. E divided by L, separate video available for explanation of RLC circuit. S minus alpha plus J beta into S minus alpha minus J beta. These two roots, alpha plus J beta, alpha minus J beta. Now we can substitute this value. 100, E is 100, L value is 0.2, S minus minus of minus 125 plus J 290.5 into S minus of minus 125 minus J 290.5. Now we can multiply this negative inside. So that 0.2 into S plus 125, minus minus become plus. This minus plus become minus, minus J 290.5. Similarly S plus 125 plus J 290.5. Here minus is minus also plus. Here also minus available plus. Now we'll go for the further simplification. So I of S is there. In order to take the inverse Laplace, we need to convert into partial fraction technique, so that we can able to take the inverse Laplace. We cannot take the inverse Laplace of this form. So this equation can be written as K1 divided by S plus 125 minus J 290.5. plus K2 divided by S plus 125 plus J 290.5. So these two terms we need to find K1 and K2. After finding the K1, K2, we can easily take the inverse Laplace transform. So next step is we need to find K1 and K2 value. Thereby we can take inverse Laplace. So these two are both are equal. Both this expression only written like this. So this 500, this term is equal to this term. Both are equal. Now we will take the LCM. For LCM on this side. These two terms will take the LCM for further simplification. Right. These two terms are taken. Here this term is available. This term not available. So multiplied here. Similarly here J plus 125 plus 290 available. This term not available. So it is multiplied here. So this term is multiplied with K1. This term is multiplied with K2. Right. Now these two terms available on both the side. So got cancelled. So finally what we have, 500 equal to K1 into this term plus K2 into this term. Here plus, here plus minus. This equation number 1. Right. So finally we got the simplified equation. So now we need to find the value of K1 and K2. So how will you find the K1 and K2? If we substitute S equal to minus 125 plus J 290.5. See here the plus is available. Plus 125 minus J 290.5. So just opposite to that, minus 125 plus J 290.5. If you substitute that, this K2 value automatically got cancelled, so that we can able to find K1. Similarly, if we substitute minus 125 minus 290 means this term got cancelled, so that we are able to find K2, right? So this value is decided accordingly to cancel any one term, either K1 or K2. So by substituting this value, this K2 term become 0. So I will substitute this value, S equal to minus 125 plus J 290.5 equal to 500 equal to K1 into this S value minus 125 plus J 290.5. Already here 125 available plus J 290.5 available, plus K2 into minus 125 plus J 290.5. But here what is available? Plus 125 minus 290.5. These two terms got cancelled and these two terms got cancelled. Here also minus 125 plus 125 got cancelled. Only we have J 290.5. Here one more J 290.5. Right. So this K2 is 0. So by adding these two we got 581. 500 equal to J 581 K1. Now from that we need to find the K1 value. What is the value of K1? So K1, you can bring this term in the denominator. So 500 divided by J 581. In order to remove this J term, we multiply and divide by the J. The term J is multiplied and divided in order to bring this complex term in the numerator. So 500 J equal to 581 J square. We know that J square is minus 1. So 500 divided by 581 minus. So 500 divided by 581 is 0.86. Minus is there, so minus J. So K1 equal to minus J 0.86. Similarly, we can find the K2 value. We need to substitute the S equal to minus 125 minus J 290.5. So that we can cancel K1, we can able to find K2. So this value is substituted here. K1 and K2 S value substituted. Here these two are cancelled. These two terms also got cancelled. Here 125 got cancelled. So automatically this term is 0. K1 is 0. So we have to choose the S value such that in previous case K2 term becomes 0. In this case K1 term becomes 0. Accordingly we have to choose the S value. Now here also same thing. Minus, but here minus J 581 is available. So 500 equal to K2 into minus 581 J. So K2 equal to minus 500 divided by 581 J. Here also multiplied and divided by J. Now we'll go for further simplification. So that is 500 J divided by 581 J square. So minus 500 J 581 J square is minus 1. So minus minus got cancelled. 500 divided by 581 is 0.86. Similar to previous case, only here the negative is there. Now here also negative is removed. Right? J 0.86. K1 is minus J 0.86. Here already one minus is there, so it become plus J 0.86. So we can substitute this value. This is the equation what we are using the partial technique, partial fraction technique, K1 by this term. Now we can substitute K1 and K2 value. So after substituting, what we got, minus J 0.86 divided by this term plus J 0.86 divided by this term. So by taking the inverse Laplace on both the side, we will get the transient current. That is our question. We need to find the transient current. So I of s, inverse Laplace of I of s is I of t. Right. Minus J 0.86 is constant. This 1 divided by s plus 125 minus J 290.5 can be written as this, based on this, e power minus at equal to 1 divided by s plus a. Right. Here a is nothing but 125 minus J 290.5. So that it is e power minus, this is a into t. Here also J 0.86 same thing, minus 126 plus J 290.5, where both the term is different. 125 minus is there, here 125 plus is there. Both the case we applied this value. E of minus 8 is 1 divided by s plus a. Here plus means here minus. Right. Now we got the inverse Laplace in the time domain. Now we can go for the further simplification. So this term is written. This again the term is written. Now we can split the term in order to for further simplification. Minus J 0.86 e power minus 125 t. Here t is available. T is multiplied. E power J 290.5 into t. So here also it is multiplied. Right. So e power minus 125 available in both the terms. So that taken outside. Here e power J 290.5 minus e power minus J 290.5. Both are different. Here plus, here minus. This term is commonly available. Right. So this term can be written as 2J sin 290.5. So that is based on the expression is available. E power j theta minus e power minus j theta divided by 2j equal to sin theta. So this is the formula. This multiply this 2j that side, so that e power j theta minus e power minus j theta can be written as 2j sin theta. Here theta is nothing but 290.5. So based on that, this value e power j theta minus e power minus j theta, these two terms. This theta is nothing but 290.5. So that can be written as 2j into sin theta. Theta is 290.5 t. Right. Now here the minus j, here also one j is available. J available 2 times. So j square. Already here one minus is there. 0.86 into 2. Here 2 is there. 2 e power minus 125 sin 290.5. We know that j square is minus 1. 0.86 into 2 is 1.72. Right. So j minus minus become plus. So finally 1.72 e power minus 125 t into sin 290.5 t. So this is the transient current of the given RLC circuit. So in this video I will discuss the solved problem for the RLC circuit. First we will identify the current, this underdamped condition. Then it is decided it is complex conjugate, third case. Based on that, we framed the equation using partial fraction technique. We split the equation, we identify K1 and K2 value. After that, we taken the inverse Laplace. After simplifying that, finally we got the transient current I of t. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.